Assalamu alaikum everyone. How are you guys doing? Okay, I am going over your answers right now. And I'm also reading your questions. Sir, I take your ad math. Manur, it's up to you. We have already done everything in class. So if you want to watch it, this will be good practice. If you do, if you don't, it's fine. Okay. Uh, no, I don't use the GoPro ultra expensive version. I use Sony ZV-E10. I had a webcam, but I don't know, for some reason it stopped working. But yeah, that's what I'm using now. X is less than 3 and X is greater than 15. That is the correct answer. X is less than 3 and X is greater than 15 is the correct answer. Okay, what other question did I miss? Or AS quadratics on the weekend? Are you really struggling with AS quadratics? AS quadratics is very much the same as AdMath quadratics, if you've done quadratics in AdMaths. Anyway, so I would appreciate if you guys would like the stream if you haven't done that yet. And so we can start. Okay, and do subscribe to the channel if you haven't done that either. So can you do the chapter discount? Oh, you mean discount? Okay. You mean in math? Yeah, I can do that later on. Let's see. Sir, advice for AS math students with other hard subjects. Just don't leave anything for the last minute. Just make sure that whatever concept you do in school or in class, just make sure that you revise it. Make sure you don't, normally we sort of leave the fine details for a test or the exam. So, if there's like 5 concepts and you've understood 3 of them, so you'll be like, okay, for the remaining 2 concepts, I will just catch up on them when there's a test lined up or an exam. Don't do that. Okay. Sir, May June 2023 recent में एक आप AP and GP का question आया on trick. Can you explain that? Okay, when I'm doing a stream on I do plan on solving the 2023 past paper for October-November students. So I'll do that. Okay. How to ace O-level maths in 30 days. Is that 30 days or 300 days? 30 days. 30 days. Okay, I really don't have any tip for that. I'm sorry. Just solve past papers, okay? Solve as many past papers as you can. Walaikum salam, Zubia. Good to have you. Sir, I completed my course level view and mostly Sir's in. Now the point is that my P2 of circle, coordinate geometry, mensuration, trigonometry. Okay. So, okay. So do past papers, all right? That's the best advice that I can give you at this point. Do past papers. See trigonometry that you're saying. Trigonometry is divided into so many concepts. So see what are the areas that you're struggling in, all right, in trigonometry, and then decide what are the areas you should work hard on. Okay. All right. Anyway, so like I said, just like the stream, fellas, if you haven't done that yet, and we are going to start. So here are all the concepts at a glance. Okay. And by the way, I will upload this. I'll upload the notes, inshallah, once we're done with the class, number 1. And I will upload the past paper. In fact, that I already have uploaded. I've uploaded the past paper questions. Okay. But once we are through with class, then inshallah I'll upload the solutions as well. Okay. I mean, you guys know how it works, right? I'm sure. I'm pretty sure no one has tuned in for the first time. But yeah, that's how it works. In case you didn't know, now you know. All right. Okay. So as I was saying, just a minute. Let me open up my notes here. Okay, so here we are. Like I said, we are today, inshallah, going to do coordinate geometry. Quadratics. And Friday, inshallah, I will be covering logs. Okay, so don't forget to tune in on Friday as well, which is tomorrow. I'll be doing concepts and past paper questions of logs. Okay, so I have my notes in front of me, and yes. So yeah, the correct answer to was the inequality was x is less than 3 and greater than 15. Now I will solve the quadratic inequality later on. If I solve it right now, I don't know how well your understanding of that concept is. So we'll do that later on. Anyway, let's start now. So basically, the first thing that we need to do is we need to learn how to sketch a quadratic curve. Now sometimes you may come across a question where it explicitly asks you to sketch a quadratic curve. Sometimes the question will ask you for, in fact, mostly the question will ask you to write down the coordinates of the turning point. Okay. Now, a quadratic equation, as you know, there are multiple ways of writing a quadratic equation. Okay. One is the general form, the form that we deal with all the time, which is ax squared plus bx plus c. Now, this form is suited when you have to use the quadratic formula to find the x-intercepts, okay? Or this form is best when you have to factorize it using middle term breaking, okay? But there is another form, which is called the completed square form. Now, if you can bring a quadratic equation into a completed square form, then that's it. You pretty much know how to sketch it, okay? Why is that? Because when you're sketching a quadratic curve, the most important thing that you need is the turning point. And because a quadratic curve will always have a turning point, it may or may not have x-intercepts. It will definitely have a y-intercept, but turning point is perhaps the most important thing, because through the turning point, we determine the maximum or the minimum point, okay? Sir, I kindly request to start teaching P3 and S2. Okay, request noted. Inshallah, from next year, I will start P3 as well. Do you think October, November? Okay, I am really not in a position to tell you guys whether the October, November exam will be easy or difficult. Okay, so this, by the way, like I said, is the completed square form, which is suited if you want the turning point. And then you have the factorized form. Now, you may not be able to bring every equation into a factorized form, but if you can do middle term breaking, then you can factorize it. Okay, this is called the factorized form. And this is the general form. Now, the reason why we bring it in completed square form is so that we can find out the turning point. Okay, as every quadratic curve is going to have a turning point. And what is the turning point? What are the coordinates of the turning point? H comma k, where h is the x coordinate of the turning point and k is the y coordinate of the turning point. What is your question? How can I get better at it? I'm just stuck in every second part. How would I get better? Learn past paper videos, that effect. Yeah, so watch my past paper videos and solve the questions alongside, and that will help, inshallah. Okay, and see what concept it is. Try and identify what concept it is that you're lacking and build upon that. Okay. All right. Now, a quadratic curve can be of two types. Can you guys tell me what two types it can be? A quadratic curve. Here is the x-axis. Here is the y-axis. Sir, can you do a... Yes, I can. Don't worry about it. I will do it, inshallah. So here is one. Okay. What do we call this? We call this a minimum curve. Okay. A curve like this is a quadratic curve. Now it's a freehand drawing. Okay. But this curve is called a minimum curve. Now, why do we call it a minimum curve? Why is the first curve called a minimum curve and this curve that I'm drawing now called a maximum curve? Can one of you answer? Can some of you, can anyone answer that question? Sir, do you remember me? Saad Samir from Nixer? Okay. If you're that Saad, then yes, I remember you. Also, smiley face and sad face. Okay. All right, so the reason why we call a minimum curve is because a minimum curve has a minimum point and a maximum curve has a maximum point. Okay. Now, this point right here is the turning point. Okay. And the coordinates of the turning point are h comma k. Okay. Now, h comma k are just letters that we use to represent the coordinates of the turning point. Okay. And what are the other important points on this curve? Another important point on this curve is this point, which is the y-intercept. Okay, and we have two other important points, the x-intercept number 1 and x-intercept number 2. Okay, and this, by the way, like I mentioned, is a minimum curve. Now, this, on the other hand, is a maximum curve. Okay, and here also we have a turning point, and the coordinates of the turning point are the same in the sense that we label them the exact same with the exact same letters, h comma k. We have a y-intercept, which we normally refer to as c. Okay, and we have two x-intercepts, x1, x2. Okay, and here also the coordinates of the turning point, like I mentioned earlier, are h comma k. Okay. Now remember, the reason why we call it a maximum curve is because the y coordinate of the turning point is its maximum value, and the reason why we call a minimum curve is because the y coordinate of the turning point is its minimum value. Okay, so remember that. That's the reason why we call them maximum and minimum curves. Okay. So that means in order to sketch a curve, if you are ever asked to sketch a curve, there are three things you need to take into consideration. What are those three things? Number one, you need to know what the nature is. Very important, in the sense whether it's going to be a maximum curve or a minimum curve. Okay, and number two, you need to know what the turning point is going to be. Again, very important. And number three, you need to know the intercepts. Now, when we say intercepts, we mean the x and the y-intercept. Now, I'll put a star on x-intercepts. Reason is that a curve may not always have x-intercepts. Okay, a curve may not always have x-intercepts. It will definitely have a turning point. We're talking about a quadratic curve here. Okay, so a quadratic curve may not always have x-intercepts. It will definitely have a y-intercept, and it will definitely have a turning point. Okay. Now, the question is, how do we determine all these things? How do we determine the nature? How do we determine the turning point? How do we determine the intercepts? Now, finding out the nature and the intercepts are the easy part. I mean, are pretty easy. But finding out the turning point is where we will spend most of the time. Okay. So, if let's say you want to find out the nature, the way to determine the nature is very simple. You look at the coefficient of x square. If the coefficient of x square is greater than 0, that means it's going to be a maximum curve. And if the coefficient of x square is less than 0, that means it's going to be a minimum curve. Yeah, greater than 0, it's a I think I said it the other way around. Sorry. If it's greater than 0, it's a minimum curve. And if that means it's going to be something like this. And if it's less than 0, it's going to be a maximum curve. That means something like this. And what's A? A is the coefficient of x squared. Did I say the other way around? Anyway, forget what I said. Just remember what I've written over here. Okay. Then we have the most important thing about a quadratic curve, and that is the turning point. Okay. Where, like I said, we'll be spending the most time. Now, in order to find out the turning point, remember, we need to bring it in completed square form. Okay. In order to find out the turning point, we need to bring it in completed square form. Now, there are two ways in which you bring a curve into completed square form. One is the identity, and the other is the conventional way. Okay. Now, I have a video on completing square form. If that's something you want to have a good grip on, I suggest you go watch it. Here, I will do just like 2-3 examples, and I'm not going to spend a lot of time on it. I'll just do 3 to 4 examples max. Okay. So let's say you have y is equals to x square plus 6x plus 8. Okay. And you wish to bring this in completed square form. So how are we going to do that? Here's what we will do. Yeah, identity is where we compare coefficients. Okay. Now I will, in fact, I'll do it through identities, and the way that you do it in math, that you can learn through my video. Okay. So what you do is you basically keep x squared plus 6x plus 8 and you compare it with a x minus h the whole thing square plus k. Okay. This is called comparing of coefficients. This method is called identities, comparing of coefficients. Okay. Now what we do is we let the left hand side be as it is and we expand the right hand side. When you expand the right hand side, this is what you get: x squared minus 2 hx plus h squared, close the bracket, plus k. So what happens is that we get ax squared minus 2ahx plus ah squared plus k, and this you write down as it is: x squared plus 6x plus 8. Okay. Now we compare the coefficients. So what is the coefficient of x squared on the left hand side? It's 1. What is the coefficient of x squared on the right hand side? It's a. That means immediately we have the value of a, which is 1. Then what we do is we compare the coefficient of x, which on the left hand side is 6, on the right hand side is minus 2ah. So that means minus 2ah is equals to 6. Okay. And we replace a by 1. So minus 2 into 1 into h is equals to 6. That means h is equals to minus 3. There you go. Then we find the constant. So how do we find out the constant? A h squared plus k is equals to 8. So what's a? A is 1. What's h? Minus 3 square. Minus 3 plus k equals to 8. Now what's the constant? Constant will be the term or terms that have no x with them. So the constant on the left hand side is 8 and the constant on the right hand side is a h squared plus k. Okay. So 9 plus k is equals to 8, which means k is equals to minus 1. Okay. Now that you have all the values in place, you put this all together. So y is equals to a, which is 1, x minus minus 3, the whole thing square plus k, which then becomes minus 1. And then if you write it nicely, this is what it becomes: x plus 3, the whole thing square, minus 1. And if I ask you what are the coordinates of the turning point, they will be minus 3, minus 1. Now remember, just remember this simple rule, and that is when you're finding out when you're from the completed square form taking the x coordinate of the turning point, you change the sign. So for example, if it's x plus 3, the x coordinate of the turning point will be minus 3. The y coordinate of the turning point, however, is taken as it is. Okay. So this is the turning point of this curve right here. Okay. Now, this was one example. If you've gotten the hang of it, that's great. If you haven't, I will do another example. Okay. And hopefully that will help. So let's say you have the following. Let's say that you have, okay. Let's say that you have the following, which is minus 2x squared plus 6x plus 5. Okay. And you wish to find out the turning point of this curve, and the way to do that obviously is by bringing it in completed square form. So here's what we'll do: minus 2x squared plus 6x plus 5, and we set it identical to a x minus h, the whole thing square plus k. Okay. Now we expand. Now once you do enough questions, you will have the expanded version of this, of the right hand side, memorized. Okay. And that's what we will use over and over again. So this becomes a x squared minus 2 ahx plus ah squared plus k. Yes, you will find this video later on my channel, nothing to worry about. Okay. Now, then what you need to do is this: compare exactly what we did earlier. So let's start with the coefficient of x squared, which is minus 2 on the left hand side, a on the right hand side. So a is equals to minus 2. Then the coefficient of x on the left hand side is 6, on the right hand side it's minus 2. A is also minus 2, h we don't know. Okay, so I've skipped a step over here. I'll add that extra layer of working. Minus 2 into a into h is the coefficient. Let me color code this as well, so it's easy for you guys to remember. minus 2ah is the coefficient of x on the left, and minus 6 is the coefficient of x on the right. There is no major difference. Okay, there is no major difference in the concepts of A-level quadratics and math quadratics. Okay, so 4h is equals to 6. That means h is equals to 3 upon 2 or 1.5. Now to find out the value of k, here is what we are going to do. A(h square plus k is equal to 5. So A(h square plus k equals to 5. Let's start plugging in the values. Minus 2 into 1.5 square plus k equals to 5. Let's simplify this, see what we get. So we get the following. 1.5 square is 2.25. 2.25 into minus 2 is going to be minus 4.5 plus k equals to 5. That means k is equals to 9.5. Now when we plug in the value, this is what we get. Y is equals to minus 2 x minus 1.5 the whole thing square plus 9.5. That means the coordinates of the turning point are 1.5 comma 9.5, and there you go. That's the answer. So this is how you find out the turning point. Okay, in order to find out the turning point, you bring it in completed square form, and then you find out the x and the y coordinates of the turning point. Now let's just discuss the intercepts as well, and then we'll straight away do some past paper questions of sketching, and then we'll do the remaining concepts. So we've learned how to find out the nature. We have learned how to find out the turning point. Now how do you find out the intercepts? That's pretty easy. That's something that we don't learn in maths. In fact, that's something we learn in math as well. In order to find out the x-intercept, what do? Completed square. Okay, I just did completed square. I used the comparing of coefficients method. The other method I will not use. I have a lot of videos on it. I would suggest you check it out through that. Okay? Because what I want to do today is I want to solve past paper questions alongside concepts. Okay? Now, how do you find out the x-intercepts? If you have a quadratic curve and you wish to find out the point or the points at which the curve is cutting the x-axis, what are you going to do? Y equals to 0. Okay. I think I already answered that question. There is no major difference. Okay. Is completing the square the only method to... No, you can use differentiation as well, but at this point I doubt you would have done differentiation. So yeah. That is another method. Okay. So in order to find out the x-intercepts, you plug in y as 0. In order to find out the y-intercept, now y-intercept will always be just 1. So you do that by finding x equals to 0. Now, when you're finding out the x-intercept, okay, so this is what you do. You have y is equals to ax square plus bx plus c. And when you plug in y as 0, you have ax square plus bx plus c equals to 0. Now, in order to solve this quadratic equation, you can obviously use factorization if possible. Okay, there's always factorization. But I think I've answered that question too many times now. Yeah, thank you. Okay. Or we can use the quadratic formula. Quadratic formula is usually the go-to method. Or we can also use the completed square form. If you have it already in completed square form, you can use that to find out the x-intercepts. Okay. Now, in order to find out the y-intercept, what do you do in order to find out the y-intercept? You plug in x as 0. So that means if you have y is equals to ax square plus bx plus c. And if you plug in x as 0, so this becomes a into 0 square plus b into 0 plus c. So y equals to c is the x-intercept, is the y-intercept. Okay. Now, let's do some past paper questions here. I've uploaded this PDF I've shared a link to it where you will find questions of this PDF. So this is the first concept, okay, right here. Now, let's solve a few questions and see what's what. So this question says write the expression x squared minus 6x plus 1 in this form where a and b are constants. Now you can do this through identities, or you can do this through the method that we do in math. It's really up to you, however you want to do it. But if you do it through identities, this is how you're going to do it. X squared minus 6x plus 1 is identical to x plus a, the whole thing square plus b. So this becomes x squared plus 2ax plus a squared plus b. Now don't think that you can only use comparing the coefficients when you have ax minus h, the whole thing square plus k. Irrespective of the form, you can still use it. Now here there's nothing to compare as far as x squared is concerned. Here the coefficient is 1, here also it's 1, so I can completely ignore this. We can straight away start with the coefficient of x, which is 2a on the right hand side and minus 6 on the left, which means a is equals to minus 3. And then we can use a squared plus b, which is equal to 1, which means minus 3 square plus b equals to 1, which means 9 plus b equals to 1, which means b is equals to minus 8. And there you go. This can be written as x, a is minus 3, so minus 3 square, and b is minus 8, so minus 8. There you go. Then it says write down the coordinates of the minimum point on the curve. Now, since it's a minimum curve, that means the coordinates of the turning point 3 comma minus 8 will not only be the coordinates of the turning point, but it will also be the minimum point. The minimum point will be the turning point. So what are the coordinates of the turning point of this curve? 3 comma minus 8. There you go. That's the answer. Okay, so you can expect questions like these. They come very often, where you're supposed to write down where you're supposed to first bring it in completed square form, and then you're asked to write down the coordinates of the turning point. Okay, the minimum point or the maximum point, depending on the nature. Not minus 3 and minus 8, 3 and minus 8. Okay, a is minus 3, so that means the x, remember, whenever we're taking the x coordinate of the turning point, we change the sign. So if it's x minus 3 whole square, it's going to be, the x coordinate of the turning point is going to be 3. Okay, so quickly, I would like you guys to solve this question. I'll give you 5 minutes. Solve this question. When you have the answer, do share it with me. I've already done a stream for differentiation. I will inshallah do another stream very soon, starting with the initial topics. Maybe I'll do a stream on quadratics, or maybe I'll do a stream on coordinate geometry. I think I'll probably do a stream on coordinate geometry. If you have any suggestions, then do let me know. Circles of coordinate geometry. Yes, that is confusing. I have done a stream on equation of circles. I did one last year. But yeah, I will do one again. I'll do one again soon. Okay, So we have an answer. Looks like we have an answer. Yeah. 9x minus 6 minus 3. Okay, let me just double check. Seems all right. No, actually, it is, I'm afraid, incorrect. Yep, that's not correct. I'll solve it quickly. Pay close attention. So you have 9x square minus 12x plus 5. Okay. Which is identical to p x minus q, the whole thing square, plus r. Now if you expand the right hand side, you have p x square minus 2qx plus q square, close the bracket, plus r. So that means you have px square minus 2pqx. Let's see, just hold on to your answer. Plus pq square plus r. Okay. So we're comparing this with 9x square minus 12x plus 5. Okay. So straight away we know what the value of p is. The coefficient of x square on the left hand side is 9, on the right is p. So p is equals to 9. The coefficient of x on the left hand side is minus 12. Let me do this with a different color. And the coefficient of x on the right hand side is minus 2. Okay. So minus 12 equals to minus 2. Let me add an additional layer of working over here. Minus 2pq is equals to minus 12. So first things first, you can cross out the negatives. So minus 2 into 9 into q is equals to minus 12. So you cross this out. Q is equals to 12 upon 9 times 2, which is 18. That means q is equals to 2 upon 3. Okay. Not 6. I don't know how you guys got 6. But it's actually, okay, I think I know what you guys did. Those of you who are saying 6, you probably did 12 minus 18 instead of 12 upon 18. Tell me if I'm right. Then you look at the constant, which is pq square plus r on the left hand side and 5 on the right. So p is equals to 9, q is equals to 2 upon 3, the whole thing square plus r, which is equal to 5. So that means 9 into 4 upon 9 plus r equals to 5. So we cross this out, and r is equals to 5 minus 4, which is equal to 1. And there you go. Now we know what it's equal to. 9 into x minus 2 upon 3, the whole thing square, plus 1. Now what are the coordinates of the minimum point? The coordinates of the minimum point will be 2 upon 3, comma 1. And there you go. That's the answer. Now, any questions? I hope not. I hope you guys have realized what you were doing wrong earlier. Okay. Let's move on to the next concept. So let's cross out what we have done. We have done sketching. Okay, there you go. Now let's see what discriminant applied to a quadratic curve to find the nature of roots is all about. Okay. So this is concept number 2. Now let me ask you guys a question. How many ways can a quadratic curve cut the x-axis? Maximum. What are the maximum number of x-intercepts a quadratic curve can have? Okay. I wish I could. Given that didn't lead to me losing my own. But yeah, if that was possible, I would have. Okay. All right, now question for you guys. Yeah, so 2. Okay. That means the maximum number of x-intercepts a quadratic curve can have is 2. Doesn't matter whether it's a minimum curve or a maximum curve. The maximum number of times a curve, quadratic curve in particular, can cut the x-axis is 2. Okay. Now, does that mean that it will always cut the x-axis at 2 points? Nope, not at all. It's possible that a quadratic curve may not cut the x-axis at all. Okay, it's possible that a quadratic curve is just hovering or is completely above the x-axis. Okay, that's very much possible. So in which case I will erase this. And just like that, it's possible that a quadratic curve remains tangent to the x-axis. Okay, something like this. Okay, now, so basically what these are, what x-intercepts are, there is a new name for it, and the new name is roots. Okay, from now on we will call x-intercepts as roots. Okay, now let me write that down over here. Okay, just a minute, let me quickly restart the app. Just 1 minute. Yeah, there you go. So as I was saying, that roots are basically a new term for x-intercepts. Okay, that's what we will refer to x-intercepts now. So in the first case, what do we say about the nature of roots? We say no real roots. All right, no real roots, or we say imaginary roots, or we say that the curve lies above or below the x-axis. Okay, that's also something we say. Or sometimes we say that it's always positive or always negative. Okay, more about that later. But in all these cases, there is something we call the discriminant. Now, what is the discriminant? If you guys have seen the quadratic formula, I'm sure you must have. I'm sure we all have here seen what the quadratic formula looks like. But discriminant is basically a part of the quadratic formula. So x is equals to minus b plus minus square root of b square minus 4ac divided by 2a. So just this part of the quadratic formula, just this part, is basically the discriminant. Okay, and now this is something that helps us discriminate in between the nature of roots. So what is b square minus 4ac? This is the discriminant. And what's the purpose? The purpose is to help us discriminate between the nature of roots. So what will the discriminant look like if the curve is not cutting the x-axis at all, or in other words, the curve has no real roots? In that case, the discriminant b square minus 4ac will be less than 0. Okay, now at this point you may be wondering what will a question look like. Don't worry about that. We'll figure it out later when we get there. Okay. And then what if a curve is tangent to the x-axis? So in this case, the terms that the examiner might use may be real and equal roots. Real and equal roots. Okay, or the question might say that the curve is tangent to the x-axis. Or the question might say that you have repeating roots. In all these cases, the discriminant is going to be equal to 0. b square minus 4ac will be equal to 0. And what if the quadratic curve is cutting the x-axis at 2 points? In that case, the terms that you might come across are the following. The question might say real and distinct roots. The question might say that it cuts the x-axis at 2 points. It might say that. Okay. And in all these cases, the discriminant b square minus 4ac is going to be greater than 0. Okay. Now, without the help of an example, this concept will not be clear. I completely understand that. So what we're going to do now is we're going to do some example questions to see what's what. Okay, so here we have some example questions which we are going to solve. And this, by the way, is concept number 2. Okay, that is discriminant applied to a quadratic curve to find the nature of roots. And that's what I've highlighted in blue. Okay, so it says here, find the set of values for which the equation has no real roots. Now, chances are that you might solve this and you end up with, in fact, not in this, but usually what happens is that you might solve this and end up with a quadratic inequality. But in this case, that won't happen. So first things first, if it says no real roots, what does that tell us about the discriminant? That tells us that b square minus 4ac is going to be less than 0. Okay. Now, how do we find out the values of a, b, and c? Remember, for that, you need to compare it with the general form of a quadratic equation. So a, as you can see, is k. B, as you can see, is 3. And c, as you can see, is minus 4 plus k. Or a better way of writing that would be k minus 4. Okay. So this is what we're going to do. B square means that we have 3 square minus 4 into a. Actually, we will end up with a quadratic equation, but that's okay. Quadratic inequality into k minus 4 is less than 0. Okay. So let's see what do we get. So 9 minus 4k into k minus 4 is less than 0. So that means 9 minus 4k square plus 16k is less than 0. So through this, let's learn quadratic inequalities as well. First of all, let's write this nicely. We have minus 4k square plus 16k plus 9 less than 0. Okay. Now, whenever you're solving a quadratic equation, it is always recommended that you first write the term with square as positive. Okay, so that's what we're going to do. We're going to look at the coefficient of k square, which is minus 4, and we're going to turn this positive. Now, how can we do that? We can do that by simply multiplying the entire equation by minus 1. Okay, so that's what I plan on doing. So if I multiply both sides of the inequality by minus 1, what will happen as a result? Question for you guys. If both, yes, we flip the sign. Thank you. So 4k square minus 16k minus 9 will now be greater than 0. Okay. So let's solve this like we would solve any other quadratic equation. So 9 into 4 is 36. Factors of 36 that leave you with minus 16. We're doing middle term breaking. So that'll be minus 18 and plus 2. Again, being AdMath students, make sure that concepts like middle term breaking are top notch. Okay. So we take 2k common. We have 2k minus 9. And then we take 1 common. Since there's nothing we can actually take common other than 1. So we have 2k plus 1. And 2k minus 9 greater than 0. For a minute, let's assume that this is a quadratic equation, which means 2k plus 1 into 2k minus 9 is equal to 0. If we solve this like a quadratic equation, that means k would be equal to minus 1 upon 2 or k would be equal to 9 upon 2. That means that we are looking at a quadratic curve which cuts the x-axis. Now, you might think that this is k, but we are making it on the x-axis. That's okay, nothing to worry about. Just think of x as k. Okay. So we have intercepts as 9 upon 2 and minus 1 upon 2. So we're just making a rough sketch here. Now, notice what is it that we wanted to solve. We wanted to solve 4k square minus 16k minus 9 greater than 0. That means we want the range where the y values are positive. We want the range of k where y values are positive, or in other words, we want the range of k where the y values are above the x-axis. Range of k where the y values are above the horizontal axis. Okay, now x and k are technically representing the same thing. So one is this range of k, that means k is greater than 9 upon 2. And the other range of k is less than minus 1 upon 2. Okay, so this is the final answer to this question. Now have a good look at it and let me know if you have any questions. In the meantime, I'll pull out some other question. What about inner range? Inner range is something we need when it's less than 0. Okay, that is when we need the inner range. All right. Yes, it's always recommended that you show your full working. Okay, because it's better for you. And not only for you, in fact, it's better for the examiner as well. Okay. As far as the calculator is concerned, you can always use your calculator to check the answer. Okay, let's do another question revolving around the same concept. And here it is. So it says here, given that the graph of y is equals to 2k plus 5 x square plus kx plus 1 does not meet the x-axis, find the possible values of k. Okay, does not meet the x-axis means that it's entirely either above or entirely below the x-axis, which means that the discriminant is going to be less than 0. Okay, so if you compare this with ax square plus bx plus k, let's see what happens. A is 2k plus 5, b is k, and c is 1. So b square, which means k square, minus 4 into 2k plus 5 into c, which is 1, is less than 0. So we have k square minus 8k, and minus 4 into 5 is going to be minus 20, is less than 0. So again, we have ended up with a quadratic inequality, which we're going to solve like we would solve any other quadratic equation. So let's do that. K square minus 10 and positive 2 are the two numbers that you're looking for that we can use for middle term breaking. So minus 10k plus 2k minus 20 is less than 0. Now if you factor out k, we have k minus 10, and then here if you factor out 2, we have k minus 10 again, which is less than 0, which means k plus 2 or k minus 10 is less than 0. Now if we were solving a quadratic equation, k would have been equal to minus 2, or the same k would have been equal to 10. But remember, we're solving a quadratic inequality. That means we want the range of k where this curve is less than 0. So the intercepts are 10 and minus 2. So let's make a rough quadratic curve. Now, since it's less than 0, that means we want the range where this curve is below the horizontal axis. Now, what is the range of k where this curve is below the horizontal axis? You can see it's in between minus 2 and 10. Okay, so if it's in between minus 2 and 10, that means k is greater than minus 2 and k is less than 10. And there you go. That's the answer. Okay. Let's do another question. Yep, that is correct. K is greater than minus 2 and less than 10. So I'll give you guys a question to solve this time. Okay, so I'd like you guys to try and solve this question. And when you have the answer, do share it with me. Cubic equation. What's your question? When will you upload videos? So I have started streaming A levels. Okay, let me know what specific topic. So I usually do a Q&A on my Instagram where I get an idea what topics you guys want me to make videos on, and then I decide accordingly. Cubic equation. I already have videos on cubic equations. There's not much in cubic equations, by the way. So let's see if time allows. Let's see. You're welcome. What do these color coding mean? So basically I've highlighted the important concepts, okay? Like why is the 3 blue? So if you look at the, if you look at the first page, you will notice that I've highlighted the main concepts, okay? And I've seen the questions, and because most of the questions will revolve around these 5 concepts only, okay? So whichever question has this concept, discriminant applied to a quadratic curve to find the nature of roots, that is what I've highlighted in blue. All right. K is less than minus 15 and K is greater than minus 3. All right, sounds good. I don't teach in a school anymore. I was teaching last year at Nixer O levels, not A levels. But I don't do that anymore. Okay, so I'll solve this now. First of all, if you compare it with ax squared plus bx plus c equals to 0, so you can see that a is equals to 1. You can see that b is equal to k plus 9, and you can see that c is equals to 9. So since it's 2 distinct real roots, that means b squared minus 4ac is greater than 0. So b square, which means k plus 9, the whole thing square, minus 4 into a into 9 is greater than 0, which means now you can expand it and then solve it, or you can reveal my YouTube earning. Okay, you'll be surprised. Or you can just shift this to the right hand side, take square root and then solve. Okay, thank you. K squared plus 18k plus 81, 4 into 9 is 36, is greater than 0, which means k squared plus 18k plus, what's 81 minus 36? Okay, my mental maths is not that good. It's 45. Okay, there you go. Is greater than 0. So we'll do middle term breaking. 3 and 15 are the terms that you're looking for. K squared plus 3k plus 15k plus 45 is greater than 0. Let's factor out k plus 3. Let's factor out 15. K plus 3 again, greater than 0. That means k plus 15 and k plus 3 is greater than 0, which means that k is equal to minus 15 or k is equals to minus 3. Okay. Now remember, we had to solve a quadratic inequality and not a quadratic equation. So we have two intercepts, minus 3 and minus 15. So this is what we're looking at. And we have to solve this for greater than 0. That means we want the part of the curve, we want the range of k for which the curve is above the horizontal axis. So one range would be, so since we're on the right side of -3, that means k is greater than -3. And since we're on the left side of -15, that means k would be less than -15. And there you go. That's the answer. Yeah, I've heard about HSN College, but that's all I know about it. Like, I don't know how it is or anything about the teachers. Thank you, Sheikh Mahimim. I hope I'm pronouncing your name correctly. All right, now let's do the second to last concept of quadratic equation. So we're kind of done with this, and we're done with quadratic inequalities as well. Okay. Let's see how a discriminant is applied to a quadratic curve in a straight line. Now this isn't any different from concept number 3. Do I end up getting my values right most of the times, but sometimes I mess up the signs? So to make sure that you don't mess up the signs, the one thing that I can offer you is, the one tip that I can offer you is make a curve. Make a curve and then see whether it's on the right side or left side. If it's on the right side, it's greater. If it's on the left side, it's lesser. That's the best tip that I can give to you, honestly. And a lot of times people look for like some magic tips, but there are no magic tips. It's just that you have to do it the hard way to make sure that you get it right. No, I don't do that. And no, I don't live in Lahore. I live in Karachi. Okay, so discriminant applied to a quadratic curve in a straight line. Now, a quick question: if let's say you have a line, upward sloping line, what is the maximum number of ways an upward sloping line can cut the, or any line for that matter, cut the quadratic curve? So let's say we have a curve right here. Okay. And you have a straight line that goes straight through. So the maximum number of ways that a line can intersect a curve is 2. Okay, so you have x and y. So in this case, basically what will happen is this. It's fairly straightforward. 3 ways, no, 2 ways, not 3 ways. Okay. So you will be given the equation of a curve and you will be given the equation of a straight line. Okay. And you will be asked to not find their coordinates or the points of intersection. In fact, you will be told how many x-intercepts they have. Okay, or not x-intercepts, sorry. How many points of intersection they have. You will be given something to do about the nature of the point of intersection. Okay. Whether they're 1, 2, or none. Okay. So what we do is, there are cases of discriminant that you must know. So first of all, let's see all the cases that we have. So the first case is where the curve does not intersect the line at all. Okay. The second case is where the line is tangent to the curve. And then there is a third case, which I'm sure you would have guessed by now, where the line does not intersect the curve. Okay, so here are the 3 different cases that we will be dealing with. Okay. In the first case, where it says that the line is intersecting the curve at 2 points, what is the discriminant? In that case, the discriminant is going to be greater than 0. Okay, but that's not the important part. The important part is to watch out for the terms that will be used in the question. Okay, so here in the first case, the line meets the curve at 2 points, or anything that tells you that there are 2 points of intersection. In that case, the discriminant will be greater than 0. Okay, if the line is tangent to the curve, in that case the discriminant b square minus 4ac is equal to 0. If the question tells you something where you're able to figure out that the line is not intersecting the curve, line does not intersect the curve, in that case the discriminant b square minus 4ac is less than 0. And by the way, there is a fourth case as well. Okay, there is a fourth case as well, and the fourth case is when the question only says meets the curve. Okay, so this is case 1, this is case 2, and this is case 3. There is a fourth case where the question says meets the curve. Doesn't tell you whether it meets at 2 points, doesn't tell you whether it meets only once. In that case, the discriminant b square minus 4ac is greater than or equal to 0. Okay, and just like that, there is a case over here, a fourth case, 1, 2, 3. Now, the fourth case, if the question says real roots, doesn't tell you whether they're real and equal, doesn't tell you whether they're real and distinct. In that case, what you do is you merge case number 2 and 3 and you take b square minus 4ac to be greater than or equal to 0. Okay. All right, now. So let's practice some past paper questions to see what's what. Okay, so it says here the curve y equals to so and so intersects the straight line so and so at 2 distinct points. So keywords, 2 distinct points. What are we going to do because of 2 distinct points? What are we going to do with the discriminant? Greater than 0, less than 0, equal to 0. Quick question for you guys. Your lives are now in best quality. What does that mean? I'm not sure what that means, by the way. Greater than 0. Yep, that is correct. It is going to be greater than 0. Why? Because it says 2 distinct points. That means greater than 0. Okay. Now, what you do here is... Yeah, probably. What you do over here is simple. That first thing you do is, let's say you wanted to find out the point of intersection. Sir, please answer my question. Okay, I'll do that. Let me get through this question. Okay, so first thing you do is, let's say you wanted to find out the point of intersection. In that case, you would have just solved them simultaneously. So that's what we're going to do. 2k square plus k plus 4. And we're going to equate this with k plus 4. X. Now you can open this if you want. If you don't, that's also perfectly all right, because the coefficient of x is the way that we want it to be. So what I'll do is I'll shift all the terms over to the left hand side. So we have 2x square. Now if I shift this over to the left, it's going to be minus k plus 4 into x plus k plus 4 equals to 0. Please do not make a sign error over here. 9 out of 10 times students know what to do with the discriminant. Okay, they know that they need to equate them, but 9 out of 10 times they end up making a sign error. Now a is equal to 2. If you compare this with ax square plus bx plus c, ax square plus bx plus c, b although is equals to minus k plus 4 with a minus sign outside, and c is equals to k plus 4, but for b we will ignore the minus sign. It will not make a difference. Why will it not make a difference? Let me show you. So if let's say you didn't ignore it and you decided that you were going to square it the way it is, then what's going to happen? Then what will happen is Okay, by the way, b square minus 4ac will be greater than 0. Then ultimately, when you square it, it becomes positive. Okay, so minus, once you square it, it becomes positive. So now k plus 4, the whole thing square means k square plus 8k plus 16. 4 into 2 is 8. So 8 into k will be minus 8k minus 16. Okay, is greater than 0. So what do we have now? Plus 16 minus 16 gets cancelled. No, wait a minute. I think I have made a 4 into 2 is 8. 8 4s are 32. Sorry, not 16, it's 32. Yeah. So here's what happens. Plus 8k minus 8k gets cancelled. We have k square minus 16. That's greater than 0. Now for a minute, let's say we're solving a quadratic inequality, which means k square minus 16 equals to 0, which means k square equals to 16, which means k is equals to plus minus 4. Now remember, we're not solving a quadratic equation. We're solving a quadratic inequality. So we have 4 and minus 4. So this is the curve that we're looking at. And now we want the part of the curve that is, since it's greater than 0, that means we want the part of the curve which is above the horizontal axis. So one part is obtained when we're on the right side of 4, and the other part is obtained when we're on the left side of 4. So that means k is greater than 4 and k is less than minus 4. So there you go. That's the answer. For as long as k is greater than 4 and for as long as k is less than minus 4, it's the line is intersecting the curve at two distinct points. Now, what was your question, Rayan? So I moved from O level. Okay, as far as AdMaths is concerned, they're the same. O level and IGCSE AdMaths are exactly the same. Math, however, just print the syllabus. Okay, just print the syllabus, keep the syllabus in front of you, and prepare accordingly. Okay, because there are quite a few things as far as math is concerned to watch out for. So I'm afraid if I tell you right now, I might miss something. So it's best that you take a printout of the syllabus and prepare for it accordingly. Okay. Differentiation of logarithmic functions. O level AdMaths. Share the link. Just search. I don't have the link saved with me right now. Just search for it. You'll find it. Yes, you should draw these graphs if you want to make sure that you solve the inequality correctly. Okay, I will give you guys a question to solve, and then we will be left with just one concept, which is disguised quadratics. We'll do that, and that would be the end of it. Okay, there you go. I'd like you guys to solve this. Sir, do you have any idea when the AS level board exams will start? You mean like the May June exams? So the first paper is usually in April. Yeah. The first paper is usually in April. Let me check. I got an A star in A and B. Feb March. Okay, I have no idea about the Feb March exams. We don't have Feb March exams in Pakistan, sadly. Okay, do we have an answer? Sir, if you were hoping for an A star and somehow got an A. The thing is, I'm in no position to answer that question. I don't know. I don't know how well or how you did. But if you're extremely, extremely confident and you have compared, you remember your answers, you remember your solution, and you've compared that with the marking scheme or with the solution. If the marking scheme is out, the solution is not out yet, but yeah, if you've done that, then you still think, and after doing that, you still think you deserve an A star. But you have to make sure. See, the thing is, the difference between an A and A star is of the fine details. So if you remember the fine details of your paper and you think that even even after looking at the threshold and the marking scheme, you should still end up with an A star, then yes, go ahead. Go and you should get the recheck done. Yeah, the marking schemes are out. Okay, but I was talking about the solution. Sir, could you recap the last? Beta, you can always rewind the live stream and go over it again. Okay. You're welcome. But recheck, yes, costs the same, I agree. But if your grade changes, then you get a refund, right? You get a full refund if I'm not wrong. How to get an A star in AdMaths? Keep studying. Keep studying, keep solving past papers, keep watching all the live streams, and yeah, you'll be fine. Okay, are you guys giving me an answer or should I just solve the question myself? So this is what the equation of line will be when you expand it, and this is what the equation of curve remains. 1 second. Okay. All right. I'll wait. Is giving O-level statistics paper going to be beneficial for A-level? Okay, I'm going to be completely honest with you. I haven't gone through the statistics syllabus in a very long time, the O-level statistics paper. So I really can't tell you that. Okay. Anyway, so I'll solve. So we have 4x squared plus 8x minus 8, which is equal to 4kx minus 3k. Now you shift all the terms over to the left hand side so you can scrape off the coefficient of x squared, the coefficient of x, and the constant. So minus 4kx minus 8 plus 3k equals to 0. So what is a equal to? A equals to 4. What is b equal to? 8 minus 4k. Why? Because you'll have to take x common. I've skipped a step. I'll just do it over here. 4x squared plus take x common. So you'll have 8 minus 4k. Please only take x common because you want the coefficient of x. Even if you can take something else common, don't do that. Okay. Plus 3k minus 8. So I've just rearranged them so that they look nice. A is 4, B is 8 minus 4k, and C is 3k minus 8. Okay, let's see. So b squared, now since it says does not intersect the curve, that means what are we going to do with the discriminant? B squared minus 4ac is less than 0. So b squared, which means 8 minus 4k, the whole thing square, minus 4 into 4 into 3k minus 8 is less than 0. Okay. 8 square is 16. 8 square is 64. 8 into 4 is 32, double of which is 64k, plus 16k square. Now 4 into 4 is 16. 16 into 3 will be 30 plus 18, 48. So that means minus 48k, and minus 16 into minus 8 is going to be plus. Okay, should probably use a calculator now. 16 into 8 is 128. Less than 0. Okay, so let's see if I can cross anything out. Nope, I can't cross anything out. Yeah. So we have 16k square minus 64 minus 48, which is minus 112k, and 64 plus 128 is equal to 192. Now I think I can take 16 common. Let's see. Yeah. So if I take 16 common, this becomes k square minus 7k, and let's see what is 192 divided by 16. 12 plus 12 less than 0. So 16, if you take it across, gets divided by 0, and this is what you have. K square minus 7k plus 12 is less than 0. If you can't do middle term breaking, use the quadratic formula. Okay, don't waste time trying to find out the terms, just use the quadratic formula. So 4 and 3 are the terms that you're looking for, minus 4 and minus 3 actually, to be precise. Plus 12 is less than 0. So we have k into k minus 4 minus 3 into k minus 4 is less than 0. So k minus 3 into k minus 4 is less than 0. That means k equals to 3 or k equals to 4. But remember, our job was not to solve a quadratic equation. Our job was to solve a quadratic inequality. So we have a quadratic curve cutting the horizontal axis at 3 and 4. So that means, and we want the part that is less than 0. That means below the horizontal axis. So that part we get when k is between 3 and 4. And there we go. That's the answer. Okay, now let's do the next question. In fact, let's do the next concept, which is disguised quadratics. Now, I have taken out a few questions of disguised quadratics as well. Let's do that, and that should be it. Okay, so let me do an example of disguised quadratics before I do a past paper question. So disguised quadratics again is quite self-explanatory. It is basically a quadratic equation that an equation that can be turned into a quadratic equation. That is what disguised quadratics is in a nutshell. Okay, so here we go, disguised quadratics. Let's do an example straight away. So let's say you're asked to solve this equation. Okay, you're asked to solve 4x to the power 4 minus 37x square plus 9 equals to 0. Okay, now what will be your cue to identify that it's disguised quadratics is that you look for the powers on x, and you'll always notice that the greater power of on x is double of the smaller power. Like for example, here's 4 and here is 2. Okay, so what we'll do in order to turn it into a quadratic equation is this. We'll say let x square be equal to something else, a, suppose. So what happens is that the x square from 37 becomes a, plus 9 remains as it is. Now what happens on 4 to 4x to the power 4 is this. So if x square is equals to a, then x power 4, what will that be equal to? X power 4 will be equal to a square. So that means this becomes 4a square. Now what you can do is you can solve this quadratic equation very easily by doing middle term breaking. 4a square minus 36a minus a plus 9 equals to 0. Now you take 4 along with a common, so we have a minus 9 Then we take minus 1 common, so you have a minus 9 again, which means 4a minus 1 into a minus 9 equals to 0, which means a is equals to 1 upon 4 or a is equals to 9. But at this point, don't get carried away and think this is the final answer, because you didn't have to solve for the value of a, you had to solve for the value of x. So x square is equal to 1 upon 4, or the same x square is equals to 9, which means x is equals to plus minus 1 upon 2, or x is equals to plus minus 3. Remember, when you're taking the square root, we write it with the plus minus sign. And there you go. That's the answer. Okay. Now, in past papers, you will notice that the questions are slightly different. Okay, so here's a question that I'm going to solve. This has a disguised quadratic part to it. So it says here, using your answer to part 1, solve the equation so and so. Now, first let's solve part 1 before I can use the answer. So you have 2x square minus 4x minus 7, which we're supposed to bring equal to a x minus b, the whole thing square, plus c. Now, if you expand the right hand side, this will become x square minus 2. So I'll skip a step here. Ax square minus 2abx plus ab square plus c. Okay. And on the left hand side, we have 2x square minus 4x minus 7. So what is a equal to? A is immediately equal to 2, and minus 2ab equals to minus 4. This cancels out. A is 2, so that means 4b equals to 4, which means b is equals to 1. And now to find out the value of c, we compare the constants. ab square plus c equals to minus 7. A is 2, b is 1, plus c equals to minus 7, which means c is equals to minus 7 minus 2, that's minus 9. And there you go. This can be written as 2x minus 1, the whole thing square, minus 9. Now let me double check before we move on to the next part. Okay, so far so good. Okay, then it says use your answer to part 1. Now, if you compare the two equations here, 2x square minus 4x, let me write that again, 2x square minus 4x minus 7 equal to 0, what do you observe? You observe that x is actually equal to what? X is actually equal to under root p, okay? And that's what we're going to do. In this equation, 2x minus 1, the whole thing square, minus 9. Since x is equals to under root p, we will replace x with under root p. So 2 into under root p minus 1, the whole thing square, minus 9. And we equate it to 0, since that's what we have to solve. Okay. And why am I using this form? Because we've already converted this equation, 2p minus 4 under root p minus 7, into completed square form. Notice that there is no difference in these two. So if you can write 2x square minus 4x minus 7 as 2x minus 1, the whole thing square, minus 9. Yes, you can use this for AS level as well. That means you can write this equation in completed square form as well. All you got to do is replace x by under root p. Okay. Now, this is what we have to solve in simple terms now. 2 into root p minus 1, the whole thing square, equals to 9. Root p minus 1, the whole thing square, equals to 9 upon 2. Now, how do we go from square? How do we remove the square? We take the square root on both sides. Now, if you take the square root on both sides, that means root p minus 1 is equals to plus minus root 9 upon 2. And let's make root p the subject. Root p is equals to plus minus root 9 upon 2 plus 1. Okay. Now remember, this is still root p. In order to find out the value of p, let's see. What we need to do is we need to square both sides. So work this part out using your calculator. Okay, if you work this part out using your calculator, let's see what do we get. Square root of 9 upon 2 plus 1. And then if you square both sides to find out the value of p, the plus minus becomes irrelevant, because if it's minus, it's going to become plus. If it's plus, it will remain plus. And what's p equal to? P is equals to 9.74. And since the question says give your answer correct to 2 decimal places, so there you go. This is 2 decimal places, and that's it. That's your answer. Okay, so through this we have covered all the concepts there are, okay, of quadratics, okay. I am taking AS level math in P1. Just keep solving past papers, okay? The best tip that me or anyone for that matter can give you is that you need to keep solving past papers. And before we leave, let me just quickly double check the answer to this. Okay, yeah, that's correct. Okay, so final minute tips for someone who has a quadratic class. Practice past papers, watch out for algebraic and calculation errors, and that's it. You'll be fine. Okay, so I'll stop here, and I'll see you guys inshallah tomorrow. Tomorrow I'm streaming logs of AdMath, so don't forget to tune into that. It'll be earlier. It'll be at 4:30 p.m. inshallah. Okay, so that's it, fellas. Take care. Love it.